So here's our copper sulfate that we had stored. I have put the cap back on it, but we stored it uncapped for about a week to let it dry out. Now we want to go back through and remass our whole container to find out exactly how much moisture we have lost. So we had a starting mass of about 18.8 grams. Now we are down to 18.684. So we've lost about 0.15 grams. This is surprising since we would expect a mass much lower based on what we have if this were just copper sulfate. However, if we think about what we've created, we actually have created a hydrated salt, so this increase in mass is likely due to the water that is still bound inside the crystal complex of the copper. So, in order to find out how much copper we actually have, we're going to need to dehydrate a portion of our copper sulfate and find out how much water we lose. Here is our container of potassium aluminum sulfate. We left it uncapped and out to dry for a week. I've now come back and recapped it in order to find our final mass. So we had an initial mass of 16.898 grams, and we have a final mass of 16.747, which means we've lost about 1.5 grams of water. Now, with this, we have everything we need in order to get our final mass and calculate our percent yield based on our method. Then we can compare that yield to our theoretical yield. Here we are moving on to our next part. I have here my copper sulfate, which we have now taken and found our percent yield, and we have found that we actually have a yield greater than 100%, which means we need to figure out what is going on. Since we should not be able to have a weight greater than 100%, we suspect that we have created a hydrated salt. Since we went ahead and very thoroughly dried it by vacuum filtration and letting it sit uncapped in atmosphere, this would mean that there is water of hydration inside the crystal complex. In order to find out if this is true, we are going to use an evaporating dish and our Bunsen burner to dehydrate our crystals and find if we have lost any water. In order to do this, I'm going to take and dry my evaporating dish thoroughly under a very intense flame from my Bunsen burner. Then I will take this, mass it on my balance, and then weigh out 1 gram of my solid into my dry evaporating dish, then return it over to my Bunsen burner and heat until it is dry. In order to do this, first step will be dry our evaporating dish for 5 to 10 minutes on high heat, mass out our copper, then return and dehydrate our copper sulfate, and we wait until we have a consistent mass by checking and measuring every 20 to 30 minutes. So here I'm going to light my Bunsen burner, move my evaporating dish on top, and then adjust my cone to be very intense. I want to be thoroughly heating my evaporating dish because we want to remove all excess moisture from our crucible. Here is my potassium aluminum sulfate. Now that we had the final mass, we went through and calculated our percent yield. We found that we have a percent yield greater than 100%, which means we need to question what has happened. Since we know that we shouldn't be able to achieve a percent yield greater than 100%, I have theorized that we have created a hydrated salt. This means that there is water still stuck inside our crystal complex of our potassium aluminum sulfate. In order to prove this, I need to dehydrate my material. In order to do that, I will be taking my crucible dish right here, my Bunsen burner, and I will be heating my crucible dish for about 5 minutes under high heat to make sure that it is dry. And I will take my crucible, mass it in order to find out the mass of my dry crucible, and then I will weigh out 1 gram of my solid into my crucible, return it back to the Bunsen burner, and heat it on high again for roughly half an hour. 20 minutes to half an hour should be fine. Then I can start measuring the mass of my crucible with my solid and finding out how much water I've lost. I will do this until I have a steady mass, which means that I have dehydrated all the water from my solid and can then find out my true percent yield. So now I need to begin my process. So I'll turn on my gas, and you can see my very hot cone right there. I want to get that cone right under the bottom of my crucible so it will start heating my crucible vigorously. With that, we will let this sit for 5 minutes to dry and then go and mass it. I've let my crucible heat for about 5 minutes. Now I need to take it off using my crucible tongs, clamp thoroughly on the side, and just simply place right onto my countertop, and I will turn off my flame. We need to let the crucible cool down a little bit to where it is more easily handleable, then take it and mass it. So now that I've let my crucible cool slightly, I'm going to take it and add it here to record its mass, which is 14.293 grams. This is our mass of our crucible when it is completely dry and lacks any moisture. I will then zero my crucible, take my solid, and mass out about 1 gram into my crucible. So there we go, I got lucky and I am sitting at just around exactly 1 gram. Right there you can see that we have exactly 1 gram of copper sulfate added. So then I will take, re-zero my balance, and double check my final mass. 15.291 grams of my combined mass. Then I can take and return this to my crucible setup and heat it under my Bunsen burner. So here I have my crucible that I have just dried and let cool. I can place it on my balance, and you can see I have a final mass of my crucible of 14.494 grams. Now I can zero that, and then I will take and add 1 gram of my potassium aluminum sulfate. So I have a solid mass of 0.996 grams of my solid. Then I can lift it up, find my final mass, 15.482 grams of my combined crucible and solid. And then I will take and return this to my Bunsen burner setup and begin heating. Now that we are back at our Bunsen burner, simply reignite, place under, and then we will let this heat and watch as we remove plenty of moisture from our solid. So here's my copper sulfate. I've dried it for about 30 minutes under high heat, so I've now killed my Bunsen burner flame. I'll take it, set the crucible on my cold countertop bench. We need the crucible to cool slightly before we go and measure it, because otherwise the heat from the crucible will cause the balance to actually fluctuate in mass. Now that my crucible has cooled slightly, I will take and add it to my balance. And I can see that I have a final mass of 14.863 grams. Now I will need to go and dry the crucible again for about 5 to 10 minutes under high heat and come back and remass it. If our mass has not changed, that means that we have totally dried our solid. If our mass still lowers, we need to continue heating until we have 2 measurements in a row at minimum that show no change. Here's my potassium aluminum sulfate. It is dried for about 30 minutes. So I'm going to go ahead and remove my crucible. You can see I've already shut off my Bunsen burner. I need to let both of these cool. I need to let the crucible cool specifically because if I go and take the mass right now, the radiating heat from the crucible will actually affect the mass that we see on the balance. Here I have my potassium aluminum sulfate crucible. I've let it cool down enough to where we can go ahead and take our mass. It has a mass of 15.064 grams. Now I will take and add my crucible back to heat. We need to heat it for another 5 to 10 minutes and come back and check the mass. If we see no mass change, that means that we've removed all the water. If we still see a lower mass, we need to keep repeating our heating and measuring step until we have at minimum 2 times where the mass does not change. Here is my copper sulfate after it's been dried a second time. I can go ahead and add it, and I can see that I have a final mass of 14.844 grams. Comparing that to my previous measurement, I've still lost about 0.2 grams, which means that I should be getting close to having all the moisture removed from my product, but I need to go back and dry it again to see if I lose any more water or if my mass remains stable. Here's our potassium aluminum sulfate after it is dried another 10 minutes. It is cooled down so I can set it onto my balance. We have a final mass of 15.060 grams. Compared to our prior mass, we are only down 0.004 grams, which means that we should be very close. This is that small of a mass difference. Could simply be a margin of error. So to be safe, I will try this for another 5 minutes and come back and check the mass, but we will likely not need to go another time after that. Here is our copper sulfate after it is dried another 10 minutes. We have a final mass of 14.832. Comparing that to our previous mass, we are now down 0.011 grams. This means we will go back and dry it for about another 5 minutes, but if we do not see a significant mass change again, we can go ahead and stop, no longer heat our substance because we are getting so low now, it could almost be a margin of error. Here's our potassium aluminum sulfate. This should be our final time of massing it. Our final mass is 15.060, which is exactly the same as our prior one, which means we have eliminated all the water, so we can now stop and figure out our true percent yield. Here is our copper sulfate. This should be the last mass that we need to take. We are reading at 14.822 grams, which means we are down 0.011 grams. You can see that we are still losing water. However, we are losing minimal amounts as we go, which means that we can likely end up calling this our final mass. We will go and heat it once more to see what we end up losing, if any. Here is our copper sulfate after it is dried another 5 minutes. As you can see, our final mass now is 14.819. This means we have only gone down 0.003 grams in mass. So we can stop here, calculate our final percent yield, and see how much water we've lost in our dehydration. Now we are moving on to crystal preparation for preparation of salts. In this case, we are starting with our slow evaporation method. For this, you'll be needing to use the provided crystals in the bottles that I have here, potassium aluminum sulfate and our copper sulfate. You're going to be using the crystal that you had made last week. In this case, you need to look into your crystal and find out its solubility. So in this case, for copper sulfate, I looked into its solubility and found that it is about 35 grams per 100 grams of water when it is at 25 degrees Celsius. I have turned on the thermometer here to check our room temperature. We are at about 21 degrees Celsius. So that means I do not need to use the exact amount that I read online. However, I should still be around that. So since I'm only using 50 milliliters of water instead of 100 as I read online, I only need to use about half the mass. And so I've cut it down to around 17 grams, which I have measured out here, to prepare my saturated solution. I did the exact same for potassium aluminum sulfate. I read online that it is about 14 grams of potassium aluminum sulfate per 100 milliliters of water when we are at about 20 degrees Celsius. Since we are slightly above that, I have gone ahead and added more. I am using roughly 8 grams, which would mean I'd be at 16 grams per 100 milliliters. So now I have 50 mils of water in each of my beakers. I can get them stirring and then add in my salts. And then these solutions will need to stir for about 30 minutes. As a reminder, again, you will not be doing both of these salts. I am only showing you the same method with both salts. You will only be using the hydrated salt that you created last week. Here's our second method, slow solvent diffusion. To start it, we are going to need to make our salt solutions. For our copper sulfate pentahydrate, if this is the salt you made last week, we are going to need to go and make a 0.4 molar solution, 50 mils of it. So in this case, I've already done my calculation, and I know that I need to use about 4.99 grams for 50 mils of water to make a 0.4 molar solution. And then if you used potassium aluminum sulfate last week as your salt, you are going to need to take 5 grams of it, dissolve it in 50 milliliters of water. So I will simply go ahead, add my salts, and then I want to wash my whey boat with my water, since you can see I have quite a bit of salt remaining. And now I have my 50 milliliters of my copper sulfate solution ready to stir. And we just want to stir this until it is dissolved. Next, for the potassium aluminum sulfate, pour it in, rinse with our water. Once both of these are fully dissolved, we can then move on to the next step, preparing our solvent diffusion. My 30 minutes have passed for my copper sulfate and potassium aluminum sulfate solutions for our slow evaporation. Looking at the two of them, I can see that I have plenty of solid left over in my potassium aluminum sulfate solution, showing that this should be at full saturation. We will need to test for later. As you can see, the bottom is covered with our salt. However, for our copper sulfate solution, looking inside of it, I can only see 1 or 2 grains of copper sulfate left over, which makes me bring into question if this solution is truly saturated or not. So I'm going to take and add 1 more gram of my copper sulfate to my solution, and then just let it stir for another 10 minutes, and then come back and check if it is saturated. Here are our solutions for our slow solvent diffusion. We have our copper sulfate solution here, and our potassium aluminum sulfate solution here. Now that they are done stirring, I'm going to take and decant them into a clean beaker. Now that I have my 2 solutions decanted into their beaker, I can go ahead and move on to the next step, which is going to be preparing our test tube filled with the solution. So I will start with my copper sulfate, and I simply want to fill the test tube about 1/3 full with my salt solution. So I will fill to about there, and then I'm going to need to tilt the test tube at about a 10 to 15 degree angle. I will have that right here, and then we are going to need to add 95% ethanol down the side of our test tube. We'll be using our plastic dropper for that. So this is simply go ahead and get an entire dropper full, put the test tube close to the surface, and you just slowly add your ethanol. And as you can see, we have our immiscible ethanol and water layer now separating. And then we are simply going to keep adding ethanol in this method until we are about 2 to 3 centimeters from the top. On this test tube, that is about at the top of the white label that is on the side. So I can just keep carefully adding my ethanol. You do not want to add too rapidly because we do not want the layers to mix. We want them to stay separated. This is the key component for crystal growth. Now that I am quite a ways up from my water layer, I can add a little faster, but still not with too much force. As you can see, this will take roughly 20 to 30 milliliters of ethanol in order to accomplish. And now that I am near the top, I will stop, take one of my number 2 rubber stoppers, and stopper the solution. And now this is ready to go and sit in my drawer and slowly develop crystals. So I will take and remove it from my clamp here, set it in my test tube rack, and then I can set up my potassium aluminum sulfate, which is done in the exact same method. I will take and fill it roughly 1/3 full. I will say right about there, and then I will tilt my solution and then begin adding my ethanol. Now that I am at 2 to 3 centimeters from the top, again, I'll just place my rubber stopper on, cap it, and then move it. And now I can go ahead label my test tubes and put them into my drawer. Here is our copper sulfate saturated solution. We have let it sit for 30 minutes to settle after it has been stirred for 30 minutes to saturation. So now I need to test to make sure we are at the saturation point. To do this, I'll be taking my glass stir rod and disturbing the solution. If we see a wispy or wavy pattern right near the crystals, that means that we are not at saturation and we need to let the solution stir for another 10 minutes, settle, and retest. So I'll put in my stir rod, quickly disturb. I am not seeing any wavy or wispy patterns through my solution, which means that I am at saturation. Here's our potassium aluminum sulfate solution after it has rested for 30 minutes and been allowed to settle. This is our saturated solution, so it has been stirred for 30 minutes to saturation. In order to check if it is truly at its saturation point, I'm going to be taking my glass stir rod here and disturbing my solution. I need to be looking for a wavy or wispy pattern in the solution just above where the crystals are currently. When I stir, it will disturb the solution, which can move the crystals. So I will take my stir rod, put it in, and then swirl. And looking in my solution, I am not noticing any wavy or wispy patterns right near where the crystals are, which means that our solution is at saturation. Now that we have tested both of our solutions to make sure that they are at saturation, I can go ahead and decant them into a clean new beaker and prepare them for storage in my drawer. So I will take my copper sulfate, very slowly decant in order to leave all the solid behind. We only want our solution. And just like that, you can see I have left all my crystals behind in my beaker. I have transferred all of my solution. So now I can take some rubber bands that I've been provided. I can place a sheet of scrap paper over top, take my rubber band and seal the top of my beaker. This is to create a barrier and stop dust from getting in. However, this does not stop our evaporation that we need in order to produce our crystals. So now I'll go ahead and repeat the same thing with my potassium aluminum sulfate. Simply take and decant slowly. I have all my solid left behind, and my saturated solution is now in my beaker. Taking a rubber band and a piece of scrap paper, I will simply place it over the top. Create my barrier against dust, and now both of my solutions are prepared to be stored in my drawer for the next coming weeks. Now that 1 week has passed and we have crystal growth, we are going to need to take a crystal from our slow solvent evaporation and use some copper wire to string and hang the crystal in the middle of the solution in order to grow outwards. So what I'm going to need to do is uncap my salt solution, and then I can observe inside. As you see, I have a large amount of crystals growing on the bottom. I'm going to go in and take, with my tweezers, one of the larger crystals. As you can see, I have a very large crystal right here. And then I'm going to need to take some copper wire in order to hang it from a popsicle stick. So now I've cut a section of wire, and I can go ahead and feed it around my crystal, like so. So now my crystal will be able to suspend from my popsicle stick. So I'm going to take and now wrap the copper wire around the popsicle stick, that it is nice and secure. And then I'm going to take and unwind enough wire where my crystal will be hanging in the middle of my solution. So as you can see, I now have a crystal hanging in my solution. And I'm going to take and return my cover. Like so. You can see that my popsicle stick hangs out a little bit. That is fine, because as I observe through the side here, my crystal is still hanging in my solution. I can now leave my crystal to stay here and grow further, and we can see and watch how much more it will grow. You will only need to do that for your crystal solution, but since I have made both solutions in order to show you, I will need to repeat the same process using my potassium aluminum sulfate crystals. And as you see here, compared to my copper sulfate, I have much less crystal growth. I do have a nice large crystal still growing in the center, so that means I can take and cut another piece of my copper. And so now I will reach in here, pull out a nice large crystal, take my wire, and wrap around my crystal. So in this case, my crystal is not doing as well as the copper sulfate. So what I'm going to do instead is I'm going to make a seat in my wire, which is where we can go and just make several small circles in the wire, like so. As you see, I've just spun the wire to where it forms a small spiral in order to allow me to set a crystal in there and have it stay seated, rather than using my copper sulfate where I spun the cable around the crystal itself. So now I'm going to take and seat my potassium aluminum sulfate crystal inside of here, like so. As you can see, my crystal is now sitting between several of the spirals, and then I can take my popsicle stick, wrap my copper wire around, that way it is nice and secure, and then I just want to try to find a good height to hang my crystal from in my solution. Right about there should be good. As you can see, my crystal is hanging about halfway in solution. Now I just need to recover, start at one end, and work around. As said before, this is not to stop evaporation, this is only to stop dust and other particles from getting into our solution. So covering it just like this works wonderfully. As you can see, my crystal is still suspended in solution. It is moved a little towards one of the sides of the walls, but that is fine. Now I can set this aside along with my copper sulfate one, and I can continue waiting and watching for growth. Just to show you comparisons, as you saw, that was our slow evaporation. I also have my slow solvent diffusion test tubes. Here is our potassium aluminum sulfate. As you can see, we have a large amount of growth in our test tube, along with our copper sulfate, which does have some fair amount of growth, but comparing the two of them, you can see that the potassium aluminum sulfate has grown significantly more crystals than the copper sulfate. And as you saw with our slow evaporation, our copper sulfate had many, many more crystals than our potassium sulfate did in our slow evaporation. So as you can see, the two different methods grow crystals in a different way, and they work better for different material. You can go ahead and make a hypothesis as to why which method works better for which material.